Friends, welcome to our channel Knowledge Dhara. Today we are going to start another and last chapter of physics, that is sound. In this chapter we will study what is sounds, types of waves, mechanical waves and many more. So let's study this all topics in detail. So let's start. So let's start our chapter sound. That is chapter 6 of class 9 physics, and this is the last chapter of class 9 physics. So let's start. So before studying about what is sound, we have to study what are waves. So what are waves? So a vibratory disturbance in a medium which carries a form of energy from one point to the other point is called a wave. Means a vibratory disturbance in a medium which carries a form of energy from one point to another point is called a wave. Wave can be classified as mechanical waves and non-mechanical waves, and mechanical waves can be classified as transverse wave and longitudinal waves. So let's move ahead. So types of waves. So there are two types of waves: mechanical wave and non-mechanical wave. So the waves which need a medium to travel are called mechanical waves. The waves which need a medium to travel are known as mechanical waves. The waves which do not need any medium to travel are called non-mechanical waves. So this is just opposite of mechanical waves. So let's move ahead. Types of mechanical waves. Means here we'll study types of mechanical waves. So mechanical waves can further divided into two parts: transverse waves and longitudinal waves. So a wave in which the medium vibrates at right angles to the direction of its propagation is called a transverse wave. Means a wave in which the medium is means the wave in which the disturbance or vibration is at right angle of that direction to the propagation is called a transverse wave. So a wave in which the medium vibrates at right angle. Remember this, in transverse wave it will be right angle, and longitudinal wave it will be parallel. We will see that. So waves in which the vibration of the medium is parallel to the direction of its propagation is called a longitudinal wave. Means waves in which vibration is of the medium is parallel to the direction of its propagation, that is longitudinal wave. So let's move ahead. So now let's study what is sound. What is sound? Sound is a form of energy. Remember, sound is a form of energy which gives us the sensation of hearing. These 2 points are important, that sound is a form of energy and sensation, it gives us the sensation of hearing. So sound is a form of mechanical and longitudinal waves. It is also a form of mechanical wave as well as longitudinal wave. Sound is a wave which is a disturbance which transfers energy from one point to the another space. So let's move ahead. So now properties of sound waves. So properties of sound waves are: sound is produced in both natural and man-made sources. Natural and man-made sources, it can be a cycle of sound wave is from one compression to next rarefaction. So a cycle of a sound wave is from one compression to the next rarefaction. We'll study what is compression and rarefaction further. Sound needs a medium to propagate. Sound needs a medium to propagate. Without a medium, sound cannot travel or propagate. It cannot travel in vacuum. Sound can travel in all three states. Remember, sound can travel in all three states, and fastest in solid and slowest in gas. So let's move ahead. Now, production of sound. How sound is produced. So sound is always produced by vibrating bodies. Always by vibrating bodies. In human, sound is produced by the vibration of vocal cords. Remember this, in humans, sound is produced by vibration of vocal cords, which is also known as larynx. So in guitar and drums, sound is produced by the vibration of strings and membranes, respectively. Strings and membranes vibrate to produce sound in guitar and drums, respectively. So let's move ahead. Now, propagation of sound. How sound propagates. So the sound energy reaches to a person with a mechanical wave motion. Mechanical wave motion means it needs a medium to propagate because it is a mechanical wave. Sound needs a medium to propagate as it is a mechanical wave. We discussed this earlier only. Sound waves cannot propagate in a vacuum. So this was the propagation of sound. So let's move further. Compression and rarefactions of longitudinal wave. A compression is a region in a longitudinal wave where the particles are closest. Remember, in compression, the particles are closest together. The region where the medium is spread out is known as the rarefaction. Here you can see this part is compression and this part is rarefaction. Again this is compression, again this is rarefaction. So let's move ahead now. Now we will study characteristics of sound. So first let's study what is amplitude. This is important topic. So the maximum displacement produced in vibrating particle on either side of the mean position is called amplitude. Means maximum displacement produced in the vibrating particle on either side of the mean position is called amplitude. Means amplitude is this one. Here it is given, this from this to this, the displacement is amplitude, the displacement of wave. This is also amplitude, this is also amplitude, this all are amplitudes. And amplitude is denoted with capital A. The SI unit of amplitude is meter because it is displacement. Formula of amplitude, this is not needed in your class, so leave this formula. So let's move ahead. So what is time period? What is time period? So time period is denoted by T. First thing is this. The time taken to complete one whole oscillation of a wave is called its time period. Means completion of one whole oscillation of wave is called time period. Means from this part to this part, this will be its time period. Here it is given already, this is time period, this will be also time period. So the SI unit of time period is second. Formula of time period, this is also not needed in class 9th. Let's move ahead. Now what is frequency? What is frequency? So the number of complete oscillations made by an or any element of the wave per unit time is called frequency. The number of complete oscillations means this is complete oscillation and this is high frequency and this is low frequency. This is high frequency wave and this is low frequency wave. So frequency is denoted with small f. The SI unit of frequency is hertz. Remember this one. SI unit of frequency is hertz. Formula of frequency, frequency is equals to 1 by time period, or f is equals to 1 by t. You have to remember this as well. Frequency is equals to 1 by time period. Now let's move ahead. So what is wavelength? The distance traveled by a wave during the time in which any particle of the medium completes one vibration about its mean position is called wavelength. Means the distance traveled by a wave during the time in which the particles of medium complete one vibration. Complete one vibration means this is the wavelength. Means this from here to here, means from here to here it is completing whole one vibration. So this distance traveled in one vibration is called the wavelength. Wavelength is denoted with a Greek letter lambda. This is a Greek letter lambda. So the SI unit of wavelength is meter. Formula of wavelength. Wavelength is equals to velocity of wave by frequency, or lambda is equals to V by S. This is important formula. So let's study now what is wave velocity. What is wave velocity? So we have studied means all characters of a sound wave. Now we will study wave velocity. So the displacement traveled by a wave in per unit time is called wave velocity. This is its formula is not formula. Its definition is almost just like normal velocity we are studying in motion chapter. So displacement traveled by wave, not object. Here the wave in per unit time is called wave velocity. The wave velocity is denoted with small v only. SI unit of wave velocity is meter per second. Formula of wave velocity. Wave velocity is equals to frequency into wavelength, or V is equals to F into lambda. So let's study now characteristics of sound. So the sound energy has the following characteristics: pitch, loudness, and quality. So let's study this all three briefly. So what is pitch of a sound? What is pitch of a sound? So the characteristic of sound which is used for differentiating between the shrill and flat sound is called pitch. Means the characteristics of sound which enables us to differentiate between shrill and flat sound is called pitch. The pitch depends on the frequency of wave. The higher will be the frequency, the higher will be the pitch. Means this is high frequency, so the pitch of sound will be high, and this is low frequency, so the pitch of sound will be low. The pitch of sound is directly proportional to the frequency of the wave. This is the same thing. Pitch proportional to frequency, or pitch proportional to f, or directly proportional to f. So let's move ahead. Now what is loudness of a sound? The property of sound which we can differentiate the loudness of two sound is called loudness. Means the highness or uh, loudness of sound is called loudness. Means the property which enables us to differentiate the loudness. The loudness of a sound is directly proportional to the amplitude of the wave. Means the higher will be the amplitude, the higher will be the loudness, because loudness depends on amplitude. So loudness directly proportional to amplitude, or like loudness directly proportional to A. You can see this is high amplitude because it is the wavelength is more, and here small amplitude it is. So this one is this will be low sound, and this will be loud sound. The SI unit of loudness is decibel, dB, decibel or dB. So let's study now factors affecting the loudness. So the main factor is amplitude that we studied, density of the medium, motion of the medium, distance from the source, vibrating surface area of the source, reflectors of the sound. So let's move ahead. What is quality of sound? What is quality of a sound? The characteristics of sound that differentiate between two sounds of same pitch and loudness is called quality. The characteristic of sound which enables us to differentiate the sound which have same pitch and loudness is called quality. Quality of sound depends on the waveform. So let's move ahead now. So what is speed of sound? So the distance covered by a wave in per unit time is called speed of sound. Means speed of sound will be also V is equals to S by T. And here S is distance, not displacement. So this is what speed of sound. This is a formula, but we don't need this formula. That is easy one. The speed of sound is highest in solids, medium in liquids, and least in gases. Remember this: highest in solids, medium in liquid, and least in gas. So this can be represented as solid, liquid, gas, like this. So let's move ahead. Factors affecting the speed of sound. The factors affecting the speed of sound are density of the medium, temperature, state of medium, humidity, wind velocity. Density of medium affects temperature. When there is high temperature, the sound will move fast. Low temperature, sound will move slow. State of medium, this depends. If solid, then it will move very fast, and it is gas, it will move slow. Humidity, high humidity will help the sound to move in air more speedily or fastly. Wind velocity. So let's move ahead. So what is supersonic speed? An object is said to be in supersonic speed if it has speed more than that of sound. Means the object which have speed more than sound is called a supersonic object, or it have a supersonic speed. For example, fighter planes, rockets, and missiles have supersonic speed. So let's study now types of sound based on frequency. This is types of sound based on frequency. So there are two types of sound based on frequency: infrasonic sound and ultrasonic sound. So the sound of frequency less than 20 hertz are called infrasonic sound. Means the sound that is less than 20 hertz is called infrasonic sound. Animals like whales, elephants produce infrasonic sound, means which cannot be heard by humans. These two of them cannot be heard by humans. The sound of frequency more than 20,000 hertz are called ultrasonic sound. Means more than 20,000 hertz, the sound which have is called ultrasonic sound. Animal like dolphins, bats produce ultrasonic sound. So let's study now what is the range of hearing in humans. So range of hearing in humans. The sound of frequency between 20 hertz to 20,000 hertz can be heard by humans. Means from 20 hertz to 20,000 hertz. Human cannot hear infrasonic and ultrasonic sounds. So you can see infrasonic sound, elephant is an example. Audible frequency from 20 hertz to 20,000 hertz or 20k hertz. This is audible frequencies, and from further that is bats and dolphins. So let's move ahead now. What is reflection of sound? We have studied already in class 8 reflection of light, but here we'll study reflection of sound. So the bouncing back of sound wave in the same medium when it strikes a surface is called the reflection of sound. So this is a sound wave and it is reflected back by a reflector. So this is reflection of sound. So laws of reflection of sound. We have studied laws of reflection of light already, but here we will study laws of reflection of sound. This is totally same as of the reflection of light. Just in place of light we have to put sound. So the first law is The first law of reflection of sound states that the angle of incidence is always equal to the angle of reflection. The first law of reflection of sound states that the angle of incidence is always equal to the angle of reflection. Means this angle and this angle are equal. In this figure you can see second law. The second law of the reflection of sound states that the incident sound wave, the normal and the reflected sound wave lie in the same parallel. In this incidence ray, normal and reflected sound lie in the same parallel. So let's move ahead. Now, what is echo? What is echo? So the repetition of original sound heard after the reflection of the sound from a distant object is called an echo. The repetition of original sound heard after the reflection means multiple times we will listen a sound, that is echo. So we can hear an echo if the reflected sound reaches our ears after 1/10 of a second. So minimum distance to hear an echo is speed of sound into 1 by 10. So we will know the minimum distance to hear an echo. We know that minimum distance to hear an echo is equal to speed into sound, as we studied in previous slide. The speed of sound in air is 340 meter per second. This is speed of sound in air. So minimum distance to hear an echo. This is in air, not in water or liquid or solid. This is in air. So 340 into 1 to 1 by 10 is equal to 34 meter. So but it has to come back as well, so we will divide it by 2, so we will get 17 meter. So minimum distance to hear an echo in air is 17 meter. So let's move ahead. Condition for the formations of echo. There are three conditions for the formation of echoes. So the size of the reflecting surface should be large as compared to the wavelength of the incident sound. The size of the reflecting surface should be large as compared to the wavelength of the incident sound. The minimum distance between the source of the sound and reflector should be 17 meter. We have discussed already. The loudness of the sound enough to reach the ears. The loudness of the sound should be enough to reach the ears. So these were the conditions for the formation of echoes. So now let's study what is sonar. Sonar is a device. So sonar stand for sound navigation and ranging. Sound SO from sound, N from navigation, A from and R from ranging. So sonar is a device which is used to find the depth of sea or locate underwater objects. Sonar apparatus consists of two parts: the transmitter, the receiver. A transmitter transmits an ultrasound which is deflected back by seabed or underwater object, which is received by the receiver. So these were the apparatus. You can see here the apparatus. This is the transmitter is this one, and this is receiver. So the transmitter sends here the ultrasonic sound or ultrasound which is reflected by the seabed, and it comes to the receiver. So let's move ahead. Structure of human ear. This is the last topic. Structure of human ear. The human ear consists of three parts: outer ear, middle ear, and inner ear. This part we can divide like this. This is outer ear, this is middle ear, and this one is inner ear. This is outer, middle, and inner. Okay. So let me erase this all. So let's study what is outer ear. The outer ear is also called pinna. It collects the sound waves and directs them along the auditory canal to thin membrane called the eardrum. This part is eardrum. This part, middle ear. The inner ear or inner side of the eardrum is attached to three bones: the hammer, the anvil, and the stirrup. These bones amplify the vibration many times in the middle ear. These are three bones, this one, and this one. So there are three bones. Now, inner ear. It has cochlea and filled with fluid and has many hair cells inside. The inner cell transfers the sound through auditory nerve to the brain. So this was the structure of human ear. So here our chapter is completed. So let's study all formulae given in the chapter. Amplitude is not needed in class 9. Time period is not needed. Frequency f is equals to 1 by time period. This is needed. Lambda is equals to v by f. This is wavelength. V is equals to f into lambda. This is wave velocity. So here our chapter is completed, and for the further chapters of chemistry and biology, please subscribe our channel with Knowledge Hara and keep watching our channel. So here our class 9th physics is also completed. So thank you for watching.